Now we're in chapter 2. And in chapter 2, we're going to be studying data. We're studying data, tables, and graphs. So we're in the part of we've all answered the survey, we've collected data. And now we want to organize it. We're not going to do a whole bunch of evaluating yet, but we're going to organize and determine tendencies. For general conclusions. Okay, so now we're going to be looking at the tool I made you buy or downloaded to your smartphone, and we're going to discuss some general concepts of reading all of these tables, because we're starting with tables first. And as we started with tables, our first group deals with frequencies. All right. Well, we understand the word frequencies. Frequencies are how often we wake up at 5 in the morning, or how often we drink sodas during the day, or how often we go shopping in a month. These are frequencies that we have because mainly life is a pattern. And that means what shifts we work, how often we do work. All of these conditions are frequencies. But in mathematics and in the study of statistics, we're talking about frequency distribution. That means using the data and organizing the data. All right. So I have naturally vocabulary words, and remember, vocabulary words imply process. So here we go. Again, I've typed up the majority of it so I don't write where you can't read it, and it looks better for you. When working with large data sets, a frequency distribution or table is often helpful to organize and summarize data. A frequency distribution helps us to understand the nature of the distribution and the spread. And it's the even spread of the data. All right. right. So, what's our objective? Well, here we want to know about the vocabulary regarding frequencies because they fall into groupings that have traits and understanding. So, what are these things? Well, distribution um, is a partition of categories that are known as classes. By listing the categories along with the number of frequency, how many, uh, there are in each of the classes. So there are some things that we need to understand in the structure. And I will focus heavily on the structure as well as some mathematics. The mathematics is not difficult, but you must take good notes. That way you won't get frustrated. All right. Thing is the lower class limit. The lower is the smallest number that can belong to each of the different classes. And then we have the upper class limits, very easy. The largest, oops, well, only if your instructor typed well. The largest numbers that can belong to each of the different classes. The class boundary uh, is the uh, numbers used to separate the classes, but without the gaps created by the class limits. I put that one twice because I did better on concepts of that further in our lecture. Class midpoints, which is a little math, small math, done on home screen. Okay, this one is uh, it is can be found by adding the lower limit plus the higher limit divided by 2. All right. So we're going to be doing that to figure out the midpoint, and that's the center value. Because when we graph, we use the midpoint. And we'll get to that later in section 2.2. But you have to understand why it's vital to know what that value is. The class width is the uniform values that fall into each class, and it is the difference between the two consecutive lower limits or two consecutive uh, lower class boundaries in a frequency distribution. Now they gave us this formula, but I don't use that one. I use two consecutive lower class limits, and I'll explain that as we get to it. Now here's what I wrote to clarify. When I looked at my notes and I was getting ready to discuss it, I wanted to make sure to clarify class boundaries. Remember to split the difference between the end of one class and the beginning of the next class. And that is, you consider the rounding principle. If the digit to the right is 5 or greater, round 0.5 or greater, a half or greater, then you move to the next whole number. All right. So what we're saying is that between uh, the boundaries is what happens. So, and I'll discuss that when we get to that point. So here we have an example, and this is to understand, to understand. And this example reflects the n of the data set. And if you remember, we said that the n is the total number of the data set. So we want to know the total. Well, the frequencies, so if we say the sum, that's a sigma, implying sum of the frequencies is n. So the total number of data is a sum of the frequencies. So let's look at this example and explain all of this. Refer to the table summarizing services times in seconds of diners at a fast food restaurant. How many individuals are included in the survey? Is it possible to identify the exact values of all the original service times? And so there's a two-part. So we want the summary. So the summary that we're going to get our calculator. Just take me a minute here. Wake it up. First time I've had to use it. First, it'll have other data in here, and we're going to talk about the calculator a little bit. Okay, here we go. Come on, calculator. Move it here. See where I can make it smaller. Oh my goodness. Yeah, sorry. I should have done this before, and most of the time I do, but I had an issue here with it. Okay, so we have when you turn it on, it's the on button, and then you clear any math that's there to make it a clean palette by hitting the clear. So if I type something and I don't like it, I can clear it. So this is called the home screen, and we're going to add all of the frequencies. So we want to add all of these numbers to find the sum of the frequencies. So let's do that. Here we go. So I'm going to have the 7 plus 21. Now, understand that when you use a simulator, sometimes it is picky, and sometimes it is not. So I have to go and check everything I enter. 7, 21, 12, 2, and 4. Well, I have a plus that's not needed. And this calculator, you can use the side arrow to delete any entry that's not important to you. You can't end a sum without a plus a number. So I'm going to hit enter, and I get the value of 46. So the total number of individuals in the summary of the distribution is 46. And so this is what we're talking about in the collection of this particular data. Now notice it asks, put this up here for a minute. Is it possible to identify the exact values of all the original service times? And the answer is no, because of the rounding. And that's boundaries. In other words, if we started at 60, well, anything that starts at 60.5, I'm sorry, 59 point, sorry, because we're rounding, 59.5 and greater equals 60. And anything from 119.5, which is the number from here to here, and up equals 20, 120. And then that would mean 179.5 and up to, now remember, that's up to 120. In this case, it's 180. So between 119.5 to 120 is 120, and so on. So this would make it 239.5 and 299.5. So you can just add a 0.5 to the ends of those boundaries and using the first one as well. So no, you can't pinpoint how many of each there are. Okay, that was good. So here we're given a frequency table, and it is age, when award was won, and the frequency. And these are Academy Awards. All right. So in this one, it asks us to identify all of the parts of this frequency table. So we're going to do this. There's nothing to calculate, only to identify. So here we go. The lower class limits. Notice they want every class. So the lower is a 5, a 15, a 25, a 35, a 45, a 55, and a 65. All the lower limits. Right. The next one is the upper limits. Well, that would be the 14, the 20. Now look at the pattern. So if we start at 15, we ended at 14 prior. We started at 25, we ended at 24. So this would mean a 34, a 44, a 54, and a 64. All right. And we have to mention that last one, which is uh, the 74. So let's look at that. If these are my uppers, then I'm sorry, lower, then these are my uppers. And you can see where I arrived at these values. All right. Now, the class width. In this case, we want to know how many data are included in each class. And these are uniform because it's a frequency table. So we take the higher, say 15, and subtract the 15 for the next one and subtract the 1 from the first one, and we get a width of 10. And you can do it to any one of them. Supposing I do the last one, 65 minus the 55 is 10. So what we're saying here, it took plus 10 here, 10, 10, 10, 10, and 10. Those are all the widths. Okay, now we're learning a whole bunch. The class midpoints. Now this one is small math, and we'll do them on the home screen. Unless you're very strong with the mathematics, you don't need it. Okay, and I'm going to construct them for you. So we're saying the midpoint is the value in the middle of each class. So my first class was 5, and I'm going to add the endpoint, 4 divided by 2. All right. And then the next one is going to be 15 plus the 24 divided by 2. Then the next one is going to be 25 plus the 34 divided by 2. And then the next one is going to be the 35 plus the 44 divided by 2. And we're always looking in mathematics for the pattern, and we're going to discuss it as we go forward. So now I'm at the 45 plus the 54 divided by 2, and so on. Okay, so I'm going to go there, and then I'm going to come down here and make more room for the rest of my items. So in this case, I'm going to have the 55 plus the 64 divided by 2, the 65 plus the 74 divided by 2. All right, so now we're going to talk about this. Now understand that I know you're smart, but I'm going to show you what we can on the keys of our calculator. Take this moment. So I'm going to open parentheses because I want the numerator to include the 5 plus the 14, close parenthesis, divided by 2. And I get 9.5. And I'm going to do open parenthesis, 15 plus 24 divided by 2. Now I'm going to do the next one. Open parenthesis, 25 plus the 34 divided by 2. And are we seeing a pattern? We can see that it is a plus 10. If I could just write calmly. So we're going to do this next one and see if it's a true cycle. 35 plus the 44 divided by 2. And I get, there it is, 39 and a half. Because this is the size of our width. So the midpoints have to be separated by the 10. So now I can tell you that this is going to be what? Yes, 49 and a half, 9 and a half, and 69 and a half as the midpoint. Again, mathematics is a study of patterns, and that's how we started with mathematics to begin with. Now, the boundaries. All right, so we know that in the boundaries, we consider the first digit. Well, the first one is 60. So 60.5 is a boundary that causes 60 to occur. 59, sorry. I do that. I apologize so much. 59 and a half is before 60. And then before 120 is 119 and a half. And before 180 is 179 and a half. And before 240 is 239 and a half. And before 300 is 299 and a half. And these are the boundaries that for that sway of data where we would place them. All right. Now I've talked for almost 30 minutes, and I will stop right here and we'll take up relative frequency on the second video. Thank you for listening.